Okay, ladies and gentlemen, I'd like to welcome everybody to the May 18th meeting of the Santa Barbara County Creeks Advisory Committee. And I'd like to ask the staff to call the roll to see if we have a legal quorum to go forward.
Thank you. Ms. Lomas? Here. Ms. Weber? Here. Mr. Moldaver?
Present.
Ms. Owens? Mr. Hawkins?
Here.
Thank you.
Yeah, thank you, Jen. Item number 3 on the agenda is consideration for adoption of those marvelous draft minutes of the April meeting. And if everyone has had a chance to examine them, I was going to ask whether there are any corrections or additions to the draft minutes, and if not, if there's a motion to adopt them.
I'll make a motion to adopt.
Is there a second? All right, it's been moved and seconded to adopt the draft minutes of the April 2016 meeting as submitted. All those in favor signify by saying aye. 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 Are there any opposed? Are there any abstentions?
Yes, I believe I need to abstain because I unfortunately missed what looked like a great meeting.
If your confidence in our staff was truly unbridled, or if you'd watched the video of a life-affirming meeting, you might have courageously voted. Okay, the draft minutes are adopted. Thank you. That brings us to item number 4, adjustments to the agenda. Mr. Benson?
No adjustments.
Okay, that brings us to item number 5, public comment, where under the Ralph M. Brown Act, any member of the audience who wishes to address this committee on a relevant subject for 2 to 3 minutes that's not already on the agenda, this is your opportunity to come forward and submit your name to our staff and address the committee and the community. Is there anyone? All right, then in that case, public comment, item number 5 is closed. It brings us to item number 6, committee communications. Mr. Benson?
I do have one item, Mr. Chair. As I mentioned at last month's meeting, I received a letter of resignation from James Hawkins, who is one of our esteemed committee members, who is going to be retiring from his service on the Creeks Advisory Committee to seek a Master's of Public Policy at UC Berkeley. He's going to be starting up late summer, and so I wanted to thank James for his service to the committee. He's been a huge help to us, and we'll miss him, and we wish him luck. Thank you, James.
Mr. Benson, I thought a Creeks Committee resignation was almost as hard to get as a Supreme Court appointment. Are you saying that you recommend for acceptance his draft letter proposing early departure?
At first, I told him I wasn't going to accept it. He persuaded me that it was the right thing to do, and suggested maybe someday he'd come back with all of his additional education, and it would be worth our while. So,
yeah, not the first time he's thrown his height and weight around.
Could I just say one quick thing, Mr. Chair?
Absolutely.
I just want to say it's been a true pleasure to serve with you all, including the committee members absent tonight. This is an incredibly passionate and intelligent group of individuals on this committee, and the city is really well served to have you all looking over our creeks and this source of funding that supports the restoration of our creeks and water quality in this community. So I just want to thank you all.
Yeah, thank you. Very well said. Are there any comments about this pending resignation? I think I'll speak for all of us, as Mr. Benson did, that it's been a pleasure to serve with you as a colleague. You serve with intelligence, passion, and distinction, and during the time on the committee, you've made the city a better, more informed, wiser place than before you served. So we're all going to miss you sincerely, and best of luck in the Bay Area.
I second that.
Yeah. Okay. Any other committee communications, Mr. Benson?
No.
All right. That brings us to item number 7, Water Quality Research and Monitoring Program Update and Fiscal 2017 Research and Monitoring Plan. Dr. Jill Murray, our Water Quality Research Coordinator, will be sharing the update with us. Dr. Murray?
Thank you. So I come to you usually twice a year, and this time of year it's to propose what we want to do in the coming fiscal year, and then propose the plan and have you hopefully recommend to go ahead with it. This year, I usually start off with all of the kind of background and our driving questions and organization. I'm going to skip that this year. So for anyone who wants that background, they can ask me, or it's in all of our water quality reports and previous presentations. So I'm just going to jump into the changes from last year and then talk about some of the areas of focus, because we have a lot of projects this year and we're really going to be working on those, and I want to give you a preview of what's to come. And then give you some very brief select fiscal year 16 results, including some more preliminary testing on neonic pesticides, some work we've done on looking at the debris screens, and some bioassessment results. Usually you get a presentation from Jeff Brinkman of Ecology Consultants, and that didn't fit with his firefighting schedule this year. So I'm going to talk very briefly about his results and finish with next steps. Okay, so changes for this year. A couple of them are just organizational, moving some. The neonic project is now in a grant required project, and the toxicity testing on mission is now permit required. We move those to the top to keep us honest. We usually don't get everything done that we hope to get done in a year, and this makes sure that we get done the required sampling first and foremost. We're adding some projects. The underlined ones are the ones I'm going to tell you a little bit more about. So one is selecting the best pollutant load model that we'll use for our permit. We've added a question on drought impacts. I've talked to you about drought impacts, but it's never been stated as a research question, and hopefully we'll be talking about recovery very soon. And looking at low dissolved oxygen and bioassessment results. Adding Arroyo Burro open space. We need to be collecting baseline data for that new project. And we have an upcoming regional board requirement to devices, kind of like the debris screens, but smaller grid. So we need to start collecting baseline data for that. And then some of the projects we're done with. Sycamore Creek was listed for high sodium and high chloride a few years ago. And we collected a lot of data. We did a lot of creek walks and tried to figure out where the high conductivity and high sodium and chloride was coming from. It really appears like it's natural groundwater flow through old marine deposits. And we've communicated verbally with the regional board about that, and they are in verbal agreement that it does appear to be natural. We've sent them all of our data. And so for now, we're going to stop collecting any more data on that. We've finished sampling some for VOCs, and in a couple of select areas. We don't have the results yet, but this was a question that was triggered by some Heal the Ocean work a few years ago, saying that they were concerned about VOCs possibly getting from leaking underground storage tanks into creeks. And so we went and did some modeling to figure out where we should sample to try to find that if it is occurring. And so we've collected those samples. I'll present those results in December. And then we were going to start collecting baseline data for Laguna Creek, and that was in support of the Mission Lagoon Restoration Project, but we're not going to do that going forward. Okay, so I'll tell you about one of the big areas of our time and resources this year is going to be the neonic research. And I've given you this background before, but for those who don't know, we became interested in this pesticide a couple of years ago when we started finding it in all of the wet weather samples that we collected, and we'd never seen the same pesticide before in multiple samples. Neonics in general are the most widely used pesticides globally, and here in California and probably many other areas, imidacloprid is the dominant one, and that's the one we're finding. And it's systemic, meaning that the seeds or the roots or the soil is treated with it, and the plants take it up, and the entire plant becomes toxic. I was just at Costco and saw pallets of this kind of preventative pesticide for sale there. And it's not great for water quality because it's stable in soil for a long time, but then once water comes, it's highly soluble and can leach out quickly. And it's been shown by others that it can be harmful to aquatic insects at really low concentrations. So, here are some of the products that it's registered for in California. I couldn't fit it all on one slide. It's really in hundreds of products. It's in termite control, pet care, all kinds of things. We're finding out even, it seems like every week we're finding out something new. It's in embedded in some decking materials and in some fabrics that are used in patio furniture type material. So we've mentioned before briefly that we applied for a grant and that it had preliminary funding, but it's definitely funded. We had all these results with some low concentrations. We didn't really know what they meant ecologically. So Hunter Lenahan submitted, he's the lead PI on a proposal submitted to and funded by NOAA, National Oceanic Atmospheric Administration's California Sea Grant program, and they have every other year they do unsolicited research, which is a great program because it doesn't have any kind of defined scope. So it's like, do you have a great idea that just needs that doesn't really have a known funding stream yet for? And so it's a three-part approach. We're finding out what are the concentrations that the organisms are exposed to, for how long, what size storms, what locations. We are collecting most of the samples, and then we're sending them to our partner, Michelle Laddick at USGS in Sacramento. She's already published on neonic pesticides. She's an expert. And then what is the impact of the low concentrations on growth and reproduction of insects? And this has to be done in the laboratory for starters. And so it's laboratory toxicity tests done by Dr. Lenahan and Dr. Jay Means at UCSB and their students. And we do send samples out for toxicity tests, but they're very simple. They're 5 to 10 day tests and really just looking at how many are left at the end of the test. This is much more detailed, trying to parse it into how is feeding affected, how is growth affected, how is reproduction affected. And then with those answers, what can we predict about real populations of aquatic insects in creeks and estuaries? And so that's the modeling component. Yes?
I'm sorry, Dr. Murray, for the benefit of those who are watching live or at home, and including our council liaison, could you explain to the audience what NOAA and USGS stand for? Okay.
NOAA is the National Oceanic and Atmospheric Administration. They do the Weather Service and marine sanctuaries and they have other agencies. And then USGS is United States Geological Survey, and I think that's in Department of Interior. And so the modeling component will be done by Dr. Eric Mueller at UCSB. And we're working, we're meeting monthly. We're not going to get to the end of the laboratory experiments and say, oh, if you would have just collected this parameter, we could have done the model much better. Or if you just would have done this kind of field temp. So we're really going to keep each other, we're not working in a vacuum from each other. So Measure B is funding the USGS portion of the project. And this is money that we wanted to spend on neonic research, regardless of whether the grant got funded. And it's also serving as the match, the required match for the grant. And so we'll be going to City Council soon to ask to award that contract. Okay, another area that's going to take some time this year is model selection. And this is pollutant load modeling. And it's a new general permit requirement. The requirement for statewide is to quantify pollutant loads and pollutant load reductions achieved by the stormwater program as a whole. But each regional board is taking a different approach on the requirements. And ours is taking a pretty concrete approach that they want a runoff model that models the amounts of pollutants coming off of small catchments at the 100-acre or single storm drain scale, and to be able to rank those different catchments to say which catchments would one work on first if they could. And then as the BMPs are installed, how is water quality improved in each of those? And then summing them all up, you get the program as a whole. So this is an example of an output that a company called Second Nature did for, this is City of Salinas, but we would divide up the city and using GIS into different catchments and then run the model And then we would get here the green are the lowest, have the lowest amounts of pollutants running off during a rain event. And the purple catchments have the highest amount of pollutants running off during a rain event. And so we've been a stakeholder for the last year on a regional board-supported LIDI stands for Low Impact Development Institute. That's kind of somewhat hand in hand with the regional board, and then this consultant, Second Nature, and they've developed a model called the Total Estimation of Load Reduction. It's called TELR, and we could just go along with that and pick that. We do have some concerns about the cost and science. And so we're going to also consider, because it's really clear based on a memo that was just sent out this week to the municipalities, we're going to be interacting with these models a lot. And so we want to take the time to pick the best one that we can use. Geosyntec developed a model for this for several South Coast agencies. That one is also available to us. So we are going to hire an intern this summer, a GIS intern from UCSB, and we're working on that. And to compare the outputs, the ease of use, the costs, the benefits, the different pollutants that are used for these two different models, and also compare them to a really simple just ranking of catchments by imperviousness and see do they all come up with the same answer? Do they come up with opposite answers? And then where do we go from there? Okay, another really exciting area is trying to really get into our understanding of what causes our low bioassessment scores at some of our sites. They're urban. Yes, of course, they're in developed areas. They should have low scores for bioassessment or index of biological integrity, or IBI. We refer to them in all three of those different terms. These urban streams suffer from something that's been called in the literature urban stream syndrome. And it's known that low dissolved oxygen is one of many factors associated with urban stream syndrome. But lately, we've been wondering how much of an actual proximate cause is low dissolved oxygen. So we've been told for a long time, looking at our bioassessment results, this is these low scores. Given the habitat is okay in some ways, these low scores are kind of signs of some kind of pollution problem. You have more pollution-sensitive or pollution-tolerant organisms in these areas and fewer pollution-sensitive organisms. And we've done a lot of toxicity testing. Now, we have the neonic, that's a confounding variable now, but we know that we have low dissolved oxygen, and maybe that is the pollutant that some of these organisms are sensitive to. And so we're in communication with Fish and Wildlife and UCSB, and we're going to buy and install some more dissolved oxygen loggers where we get the round-the-clock readings and put them in where we're collecting the bioassessment scores and see if we can tackle this. Okay, now I'm moving on to brief results from FY16. We've continued to collect more neonic data. We did several storms this winter where we did multiple time points per storm at Laguna Creek. And it was, imidacloprid concentrations were low, but above some of the suggested guidelines for ecotoxicity for days at a time. So this will help guide our sampling on the grant. And so we can say that here in this urban area, aquatic insects are receiving chronic exposure to this pesticide and could be leading to problems. Okay, another little project that we did was to look at the catch basin debris screens. These were put in to reduce the trash getting into storm drains and the creeks. They were put in back in 2009. But I've seen hints of indicator bacteria concentrations going down in areas with the debris screens. It's not a uniform result, but it's enough to make me want to look into it a little bit more in detail. And the hypothesis is that these screens are keeping leaf litter out. And so that decaying leaf litter provides some nutrients for indicator bacteria to grow right in the storm drain. And I know I'm jumping into for people out there, jumping into indicator bacteria, there's a lot of background that you'll just have to be patient on and maybe look into some of our water quality reports online, because I'm just going to jump right in. So we had new watershed stewards, and we threw them this project of going asking, do these debris screens keep the leaf litter out? And if so, is there a change in indicator bacteria numbers? And we took the photos for this one section, the west side of Santa Barbara, and photos had been taken in the catch basins for trash counting before and after the screens were put in. And so we just did a simple grid system where they put that on every photo and then ranked each little rectangle in the grid based on a really simple scoring system. I didn't know how well this would work at all. We had 12 sites, and then you can get the average of each little rectangle. Okay, so the results were that the leaf litter scores did go down from pre to post, and that's on the left panel, from around 50%, or from about 100% fill to 50% fill, and that in that area for that time period there was a reduction in some indicator bacteria, and that's shown in the right panel. As I said, Shannon Mueller and Jane Westfall completed this. And there are some statistical caveats which we'll get into in the report, mainly that we only had 1 year of pre-project data, several years of post-project data. And so this led to me thinking we've got to put the trash capture monitoring in the research plan so that we start collecting that. I don't even know in what form we're going to collect that data, but we need to make a plan and start collecting it well before those trash capture devices get put in. Okay, so very briefly, you usually see the presentation by Jeff Brinkman from Ecology Consultants. He has been collecting habitat and benthic macroinvertebrate data annually, and then calculates the index of biological integrity. And in general, one result is that the upper watersheds or reference sites, sites that are surrounded by undeveloped watersheds, generally have much higher IBI scores than the lower watershed sites. But the drought has led to a situation where even those upper watershed sites now are indistinguishable from the lower watershed sites. So this is just the reference sites, and this is county-wide, not just the city. And it's the timeline from 2000 to 2015, and you can see that starting after 2012, there's just been a steady drop in the average scores, and that this last year, they're really low. And this is a comparison. Let's see, this is on the top panel, this was 2012, and the top panel, there's high disturbance, moderate disturbance, and reference sites, and you can see the average IBI score goes up as you go to reference sites. The bottom panel is 2015, and you can see that with these diamond plots that the scores for the reference sites on average are not higher than the highly disturbed sites, and that's because of pools separating, drying up, low dissolved oxygen. So that fits right in with our dissolved oxygen hypothesis. So the next steps are to ask for your recommendation to go forward with that research plan. And next, you're going to have a presentation on another one of our projects, which is led and carried out almost entirely by UCSB. We're going to help with some sampling this year. You'll hear that presentation from Dr. Jared Irvin. And then in December, I'll come back with the water quality report. And I will take any questions now.
Yeah. Thank you so much, Dr. Murray. Catch your breath for a second while you covered a huge number of investigative initiatives that you're helping to supervise. I don't think the public realizes how much science and interpretive work is going on behind the scenes. Are there any questions from members of the committee on the report from Dr. Murray? Yeah. Well, Natasha?
That was a lot of information in a very short period of time. So I only have one question. On your focus area, neonics, did you find it in other creeks, or were they absent in other creeks besides Laguna?
Ms. Lomas, we have found it in every single wet weather sample we have tested. So that's been in all 4 of our creeks and just parking lot and sidewalk runoff also. But this year we've focused mostly on Laguna Channel because we wanted to do the time series and we couldn't do that in multiple creeks. When we first find it in 2014, I believe. But we weren't testing for it before then. Really, no one requires or even suggests testing for it. The only people besides us that I know of, California Department of Pesticide Regulation has tested for it. And then all the rest that I know are academic researchers.
Thank you.
Are there any other questions? I'd like to ask, with the tremendous dispersion of neonic-related chemicals throughout the business inventory just in California, from the list of 5 slides, is Cal EPA or their federal counterparts or the state ag commissioner or the U.S. Agriculture Secretary's office doing some significant parallel scientific research to augment the local studies that you're talking about?
There is extensive work done on pollinator impacts, and I don't know exactly who's doing what there because I don't track that research. As far as the state, there is, I've heard people talk about sampling after spraying, doing the citrus spraying, and then doing some water sampling, but I've only heard of it sort of being requested, not actually being carried out. I think an Ojai NGO is working on trying to request more water sampling. As I said, Department of Pesticide Regulation has a surface monitoring program, and they are starting to get on board and testing for neonics. And they are listening to everything that is being sent their way.
Ms. Lomas?
One other question. Are fish being tested? Anything on the, lethal levels or?
We are not doing any kind of fish testing. There is a really big comprehensive review by the Task Force on Systemic Pesticides, and they have a different academic publication for each group of organisms, and vertebrates is in there. And the receptor is so different for the vertebrates compared to the insects that if it's toxic, it's at much, much, much higher concentrations. But I think you would find that paper interesting, and I'm sure that they've probably carried out the tests at high enough concentrations. But the bigger concern, I believe, is the trophic level effects, that when you start killing all the non-target insects, you're taking away the prey for fish and birds. And in some areas, they have found lower bird diversity in areas with consistently, not even high, just consistently present imidacloprid. And I don't know of any studies that have looked at fish community analysis as a response to the change in prey from neonics.
Are there any other questions or comments? Mr. Smith?
Thanks, Joe. You said we started testing for neonicotinoids in 2014. Why was it that we started that testing?
We are always trying to... We started testing it because one of our staff members read an article about the impacts to pollinators and said, should we be testing for this in creeks? We called up a lab and said, can you test for this? And they said yes. That's really how it happened. We didn't even know to test for it before that. It's a pretty new pesticide, and then the attention to pollinators has been pretty recent too, as a result of the colony collapse disorder. So if you hear of any new classes of compounds, send them our way, because we are constantly reevaluating our list of what we test for when we say we test for pesticides.
Well, Dr. Murray, our next responsibility is to get a motion and a second and a discussion and approval for the proposed 2017 fiscal year research and monitoring plan, which might be tied to a comment about your report. So let's go over here.
Thank you, Mr. Chair. I just realized that in my opening comments, I was remiss because I acknowledged the great work of the Creeks Advisory Committee, but I did not acknowledge the foundation for our work, which is the excellent contributions and daily work of staff, which Dr. Murray is an integral part of. And I just want to thank you for all your years of service to the Creeks Division and for your excellent help over all the years for this committee and myself in understanding these issues. I want to thank Mr. Benson for all his excellent work all over the years. He provides excellent leadership for this city, for the Creeks Division, and this is just such a wonderful group of individuals, probably the best staff I've ever had the pleasure of working with. Well, after 4 years of this kind of work, had the pleasure of working with. So I want to thank you all for that. And with that, I will motion to approve staff's recommendation.
Okay, do we have a second? And this would be for the research and monitoring plan outlined by Dr. Murray just now for fiscal year 2017.
I'll second that.
Thank you, Ms. Weber. It's been moved and seconded to concur in Dr. Murray's monitoring and research plan for 2017. And before we vote, I'd like to note parenthetically that as complex as this suite of research objectives is, no part of Dr. Murray's presentation in any way reminded anyone of that of Supervisor Martha McClure on or off TV or on or off the record. So it is possible for public officials to wrap their minds around really complex, important issues and still say informative and civil. There's been a motion and a second to endorse the recommendation for the research and monitoring plan for 2017. All those in favor signify by saying aye. Aye. Are there any opposed? Are there any abstentions? All right, the motion has been adopted, and I'm sure Mr. Benson will forward our recommendation. Thank you. That actually brings us to one that Dr. Murray's already teed up, which is item 7B, microbial source tracking at Ledbetter Beach and East Beach at Sycamore Creek.
So Dr. Irvin might be a familiar face, and you might be wondering why he's from Geosyntec now, and he used to be from UCSB. So Dr. Irvin came to work with Dr. Holden, our partner at UCSB. He did work and really ran the show on he did work on a lot of her projects, but really ran the show on the Arroyo Burrows source tracking project that led to the identification of the canine markers in the creeks and at the beach, and then doing the education and lowering the canine markers. And then I think Geosyntec was smart to scoop them up, and I think you were doing both. You were wearing both hats for a while, and now he is with Geosyntec and working with Brandon Steets. They helped Dr. Holden apply for the latest round of funding, so it was a natural crossover. So enjoy Dr. Irvin's presentation.
Great. Thank you, Jill, for the introduction. So, and thank you for having me today to talk about this research, this great project. So I'm going to be telling you about a project that I've been involved with for over a year, and involving the microbial source tracking to identify bacterial fecal contamination at 3 different beaches in the Santa Barbara area. And this project is a collaboration, as Jill said, between UCSB, the Bren School with Dr. Patricia Holden as the principal investigator, and Geosyntec consultants here in the Santa Barbara office. And as she already said, I'm an engineer at Geosyntec, but I came from Tricia's lab at UCSB, where I was a postdoc for just over 4 years. So the overall purpose of this study is really to perform microbial source tracking at 3 Clean Beach Initiative priority beaches in the Santa Barbara area. The 3 beaches that were selected are Ledbetter Beach, East Beach at Sycamore Creek, and Goleta Beach. And as you know, all 3 of these beaches are very popular recreation beaches with a lot of swimming, surfing, a lot of water contact recreation going on. There are also 3 beaches and watersheds that are on the state's 303D list of impaired waters due to fecal indicator bacteria. And in addition to that, these 3 beaches represent areas where in the past we had seen previous data that suggested human sources of contamination could be present, but no studies had been performed yet at the beaches. And so the overall goal of all this research really to identify the sources of human and other types of fecal contamination so that they could be either eliminated or better managed to improve water quality and protect the health of the Santa Barbara beachgoers. So the overall schedule of this study, year one studies conducted during the AB 411 period, which is the period from April to October each year when the state requires bacteria levels to be monitored at these beaches. Year one studies have already been completed last year in 2015 at Ledbetter Beach and at East Beach at Sycamore Creek. And the idea is that there's 1 year of study, and then if the data from the first year warrants further study, a second year of study will be performed at each beach. And so for this year, we have the first year of study being conducted at Goleta Beach, as well as the second year of study at the other two beaches. And then in 2017, if necessary, there would be a second year, done at Goleta Beach. So just a real quick background on fecal indicator bacteria. So these are, it's the fecal indicator bacteria concentrations in the surf zone and the creeks that have really been the driving force behind these studies. And the reason that the indicator bacteria are good is that they're found in very high concentrations in human sewage and in animal feces, and that they've been linked through in previous studies to an increase in human health risk if they're above certain levels in waters. However, they don't give any indication as to what the source of that bacteria is, and they can also persist in the environment or come from non-fecal sources, which really means that they may not necessarily indicate an elevated risk to human health, depending on the source. So microbial source tracking is a tool that we use to then determine what the actual source of fecal bacteria is in the water sample that we're looking at. We're using DNA markers to detect specific bacteria that are associated with different types of sources, and then determine what those sources are. Are the bacteria from humans, cows, dogs, gulls, and then where are those bacteria coming from? Kind of the tracking part is sampling throughout a watershed upstream to track down the source. Is it a certain storm drain that has sewage leaking into it, or a campground or area where open defecation is occurring, something like that? And although the markers haven't been developed for every possible source out there, most of the common sources to surface waters in this area have been developed, and they have been tested and validated at the Holden Lab in this area. So we have a lot of experience there. So the methods being used in this study, these are all methods that were recommended in the California Microbial Source Tracking Manual, which was a guidance manual developed for the state that the researchers from the Holden Lab, including myself, were involved in the production of that manual. Many of these methods are also given in the Santa Barbara Toolbox document. And both of these documents actually highlight the need to use traditional source tracking tools in addition to your advanced molecular tools. And so one of the things we're doing in this study is we're doing dye testing at all the beaches that we're studying. And so in addition to that, we have the two primary fecal indicator bacteria groups that we're looking for. There are general DNA markers that are being analyzed, as well as the source-associated markers. Two tests for different human markers and dogs and gulls are being looked at in this study, as well as, I should say, horse markers potentially in Goleta Beach coming up, because there's some areas where horses are present in the upstream watershed. And then chemical indicators and nutrients, so chemical indicators including caffeine and cotinine, nutrients, those are being archived as potential second lines of evidence from all these samples that are being collected. If we suspect a sewage source, those can be analyzed and could be a nice complementary bit of evidence. Pathogen samples also being archived to potentially look for the actual disease-causing bacteria or viruses that could be in these samples if we see human sources again. So all these studies are being designed using a hypothesis-driven approach where we've done a ton of background information, looking at all the past water quality data, also some preliminary sampling and on-the-ground reconnaissance to try to identify all the potential sources that we suspect to be contributing to these beaches. And so it might not be surprising that two beaches in the same area would have many of the exact same sources. So I've highlighted a few of those. Some of the sources we identified were bathrooms at the beaches, and then gulls and dogs at both beaches. And both beaches have creeks into the upstream watershed where there could be sources being conveyed downstream to the beach through those creeks as well. So for the 2015 study, that sampling during the dry weather AB411 period, there was 9 sampling locations at Ledbetter Beach, 12 sampling locations at Sycamore Creek, East Beach at Sycamore Creek, and those included Surf Zone, Creek, and a couple storm drain locations. Sampling was conducted over 6 dry weather sampling events, as well as 2 small rain events that just happened to occur during that period, which was a great addition to this study. And then those dye studies, fluorescent rhodamine dye was added to bathrooms at Ledbetter, the Shoreline Cafe, as well as the public bathrooms there, and then also the Cabrillo Bathhouse at East Beach to test those sewage infrastructure, bathrooms, and the sewer lines running from those along the beach. So this map shows the sampling locations at Ledbetter Beach. We had 5 surf zone locations spread across the beach. You can see the third one is where the county normally does their weekly monitoring for FIB. We had the outlet to the Honda Creek right at the beach where there's normally a puddle of water there, and then a couple of upstream creek locations, 8 and 9. And that's really the flowing extent of the creek. Above that, the creek is pretty much dry all the way. And then sampling site 7 was a flowing storm drain there on the west side of the beach that was just continually flowing, so we're interested in sampling that as well. And I should say that neither the creek outlet nor that flowing drain actually conveyed water all the way to the surf zone, at least over the surface. There's a sand berm there that was there throughout the summer, even during those small rain events. And so a similar design at East Beach, 5 locations across the surf zone. Sycamore Creek is locations 10, 11, 12 with the creek outlet on the beach there. And then 4 locations in and around the bird refuge area, the outlet right at the beach, the kind of across the street there where the gate is in the refuge, and that was closed throughout the entire sampling season. And then 8 and 9 are 2 locations where flows contributed to the bird refuge. And then just like for Ledbetter, neither the creek outlet nor the bird refuge outlet were flowing just connected to the surf zone. So as I went through those methods, I'm sure you can see there's been a huge amount of data that's been collected just from that first year at these 2 beaches. So I'm just going to show a couple examples of the type of data we're collecting and then kind of summarize what we've found so far. This first map shows human marker detections over those 6 dry weather sampling events at Ledbetter Beach. And the green is when the marker was not detected. The yellow is when there was a low level, and these are just barely above detection levels of the human marker. And then you would see red if there was a higher level detection. So, and what you can see here is all the upstream in the watershed sampling locations, all green, nothing human detected up there. At the beach, pretty frequent low-level human marker detections. And I should say that the 2, since I'm not showing data from both beaches, both the results have matched up, been pretty consistent between the 2 beaches. So similar at Sycamore during dry weather, although there was a couple detections in along the upstream creek in an area there where some homeless activity, trash, and I think even some toilet paper was observed along the creek there. And then in wet weather, interestingly, the upstream creeks, higher levels of human markers start showing up in both watersheds when you have that wet weather and runoff is coming from the watershed. So the second results map that I'll show you, the pie charts are set up in the same way. So you see the red level, higher level detections. This is for the gull marker during wet weather and at Sycamore. And we saw pretty consistent high-level gull marker along Sycamore Creek and in the surf zone. And again, this is 2 sampling events for those 2 wet weather storms that we were able to get samples from. But interestingly, around the bird refuge, not much gull marker. And I think we might not, and that might be surprising, but from what we've found, the gull marker pigeon is another source that also shows up with the gull marker, but other birds we don't expect to give us a positive result. So a lot of the birds around the bird refuge may not be contributing to that. So these are kind of the overall highlights from the results that we've gathered so far in our 2015 sampling at those 2 beaches. So for the dye testing, we didn't find any dye in the surf zone during our dye testing of the beach bathrooms. So no direct connection there with the bathrooms contributing bacteria to the surf zone. We did, however, we installed temporary groundwater wells to try to sample the groundwater as close to the bathrooms as we possibly could. And we did have 1 sample near the sewer line, a very low level of dye, and so it's enough that we are following up on that in this year's sampling. For the FIB, there were much more frequent exceedances of the water quality criteria in the upstream watershed compared to in the surf zone, and that was for dry and wet weather. For the human markers, it was pretty similar to what I showed you in that results figure. We had frequent detections at very low levels in the surf zone, and that was in dry and wet weather. Then in the upstream watershed, almost nothing during dry weather, and then higher levels of detection during wet weather. Dog and gull markers at both beaches, again, were very similar. There was almost always dog and gull detected across the surf zone sampling locations, and many of those samples relatively high, at least above the not quantifiable level. And then in wet weather, only really detected during wet weather in the upstream watershed, not as much during dry weather. So these are kind of the overall findings based on those results that we saw this year. And so the beach bathrooms, these are the conclusions we can kind of make. The beach bathrooms were not contributing to FIB in the surf zone based on our results. The birds and dogs were both very likely sources of bacteria to the surf zone. It appears based on the wet weather result that rainfall is mobilizing bacteria, both indicator bacteria and our DNA markers, to the creeks and lagoons. And this could be very important. While those rainfall events didn't cause flow to the surf zone, during larger rainstorms, we expect that could be a major source to the surf zone area. And then finally, the human markers consistently detected at both beaches in the surf zone. And that's the big area where the source of those markers to the surf zone samples that really at this point are not understood, and the implications of what those detections could mean. So moving into the 2016 study plans for this year, a lot of our study plans focus around determining the source of those human markers to the surf zone. Additional dye studies are going to be done at both beaches to test sewer line infrastructure, as well as dye studies to look at the groundwater flow from those creek outlets, potentially through the subsurface to the surf zone. We're also going to be doing sediment and sand sampling in the surf zone to look for bacteria there, and sediments along the creeks. It's possible that those sediments and sands could be harboring bacteria and markers. We'll be performing offshore sampling, so a couple of the potential sources are boats in the harbor. Could it be the boats in the harbor? We need to sample further out into the water to assess those sources, as well as the wastewater treatment plant effluent from El Estero. We're going to sample the effluent as well as out into the harbor, because while the indicator bacteria are generally very low in the effluent, there is some evidence that there could be DNA markers still present that would be quantifiable. And then also a reference beach, Arroyo Hondo, is going to be sampled to ensure that the markers that we're detecting aren't from some type of background source. And then briefly at Goleta Beach, the year one AB 411 sampling and dye studies will be conducted, but we're also going to be doing some sand, sediment, offshore sampling, wastewater treatment plant effluent, kind of a lot of the things that we learned from our first year at the other two beaches will also be performed during the first year at Goleta Beach. And finally, we plan on doing wet weather sampling outside of the AB 411 period because one of this data has suggested that it could be winter wet weather that is transporting material down into the beach area. Those bacteria are then persisting and causing detections during the summer dry period. So thank you again for having me. I'm just going to acknowledge the whole project team that was responsible for all of this work. Dr. Holden and Lori Van de Werforst are leading the effort at UCSB, along with Marina, Dong, and Naresh. At Geosyntec, our office here in Santa Barbara, Brandon, Avery, and myself. And then we've had lots of input and data submitted from local stakeholders, multiple agencies at the city and county, as well as Heal the Ocean and Channel Keeper. And the funding for the study is through the CBI, the Clean Beach Initiative Grant Program, and Proposition 84. And all of this data will be eventually publicly available in the final study report, which will be in 2018, after all the results in 2017 have been gathered and analyzed. So you may need to have us back before then if you want to get an update on the results. Thank you.
Yeah. Thank you very much. That was also a very rich and detailed presentation. As Dr. Murray knows, I had a special advantage. I was able to see most of this at Allison Hall at UCSB several weeks ago. But are there questions about the most recent results on the two creeks or the proposed investigative schedule for the next phase? Ms. Lomas?
Thank you. I am curious, is there any way to figure out if some of the harbor boats or any of the marina water affects the numbers in Ledbetter? Because, a lot of the boats have their own flushing system and their tanks, and they supposedly clean them out before they reach the harbor.
Right. So there is an extensive dye testing program in the harbor where any boats that come in get dye tabs put into their onboard septic tanks, and that would show. That would not keep people from potentially dumping things over the side of the boat, and so or boats further out potentially passing by. So that's one of the reasons why we are sampling further out into the harbor. If we see those, we expect if there are urban onshore sources that it'll be as you move further away from the beach, the concentrations should be dropping, the frequencies of detection should be dropping. But if they were to stay the same or increase as you get closer to the boats or around towards the harbor, then that could indicate those as sources.
How long does this dye actually stay in the water before it dissolves? Now, I've used dyes in investigating some pollution cases in my past, but they were more in creeks, so they didn't have the dilution factor in all dimensions.
Right.
Went down the stream. So, but in an ocean environment, how long does it take before it dissipates? I guess it depends on how much you put in, but like in the boat tanks. Bilge tanks.
I'm not sure. I think they'd be looking for the signal pretty much right away, testing for any leaks, and they would see it coming out. As far as the dye that we're using in the sewer lines, it does degrade eventually, but it is more persistent on the order of weeks that you would be able to measure that.
Thank you.
Any other questions?
All right, I have a few questions, so bear with me, everyone. Dr. Irving, thank you for the presentation. First off, were you all able to look at, is there any correlation between FIB indicators and low levels of human markers versus high levels of human markers?
I know correlations between all the different markers, FIB, were performed. I don't have all that data. I don't believe there were correlations between human markers and FIB. There was a correlation between the gull marker and FIB at the beaches.
Okay, that's helpful. And related to that question, how much epidemiological work has there been done related to, the low levels of human markers versus high levels of human markers? Do we have any idea of what kind of risk there is for beach users? I'm specifically talking about for human markers.
Right.
When you all detect, even like you presented, a low level of human marker at, was that at Ledbetter? Is there a significant risk or what?
It's really unknown at this point what that means, and that's one of the reasons why we are collecting samples to potentially look at pathogens. That would be another line of evidence that human waste is present. But there is a study that's just wrapping up. I think that SCORP, the Southern California Coastal Water Research Project, is conducting. They did a wet weather surfer epidemiology study at 3 beaches in Orange County, San Diego County, yeah. And so I think, as far as I know, that's the first major study where they've looked actually at human markers in correlations with risk, multiple pathogens, as well as the indicators. And so I haven't seen any finalized results from that, but there should be, those results should be available soon.
Well, I'm sure whenever you come back next, or Dr. Murray, we'd love to hear the results of that. Next thing, so in terms of your follow-up plan or just what you've already completed, did you all look at, the number of swimmers or ocean recreators in general while you guys were sampling? Is that, a potential line of hypothesis? Is there any issue of
Sure,
ocean recreators directly contributing to human markers?
Direct inputs right at the beach from people at the beach is definitely could be a source, and that wasn't investigated in the year 1 study. I think part of the second year study, I think we will be investigating that to some extent with the sand samples collected at the beach. If those inputs from people at the beach to be persisting, that's where those bacteria would be. So, interestingly, I did during the Arroyo Burro Beach study, I did do counts every time we sampled of the number of people and dogs at the beach, and so we did look at try to correlate people at the beach to human markers in the surf zone, and also did some sampling very early in the morning before people arrived, compared that to other samples that were after there was many people at the beach, and we didn't see any correlations there at Arroyo Burro.
Okay, thank you. And then just regarding the wastewater effluent sampling, so is the hypothesis there that wastewater through the El Estero outfall is impacting human markers at Ledbetter or East Beach?
Right. If the DNA marker levels were high enough in the effluent, it's a potential source. Obviously there's a lot of dilution. I mean, the diffuser along the line is designed to effectively dilute that water, but it's a source that we feel like needs to be at least investigated. Others have seen, and we have seen the markers showing up in sewage effluent and reclaimed water. Now, that doesn't necessarily represent viable bacteria. Those could just be, dead or DNA fragments that are left from the treatment process, but it could be a potential source, yes.
Okay, thank you. Just one more, and this maybe is a better question to direct to Mr. Benson or Dr. Murray, but this work is really great. We're very lucky to have it in our local community. My understanding, correct me if I'm wrong, Clean Beaches is the CBI money is exhausted at this point, or is going to be. Is there? Does the state have any plans for follow-up funding? Do you all have any idea about that?
Oops. Mr. Hawkins, I don't know what the follow-up plans are for CBI, but Dr. Holden is on the Clean Beaches Task Force, so she would be a great source of information if you want to reach out.
Thank you. Yeah, I think it would be a real shame if this was the last, tranche of Clean Beaches funding. We really, I don't think all problems are solved on this issue in California, and clearly we could, the state should, I think, step up.
I do think that one of the challenges was finding the appropriate capital projects to fix things. In some cases, there were clearly some sewer lines identified that were probably worthy of being fixed. In many cases, still more and more research needed to be done, and that really wasn't the design of that funding source.
Are there any other questions for the speaker? Well, I have one. This next year, when you're talking about having some extra wet weather focused testing, is geosyntech going to be a catalyst to try to get the reward that Mr. Casey and Mrs. Bjork have offered for facilitating wet weather in Santa Barbara?
I'm not aware of that.
That might be a bonus in your upcoming contract if you can make that happen. I want to thank you very much for the update, and I agree with James. It's great for the community to see how much sound science and constant inquiry is being made on how to get our creeks and beaches and coastal waters as clean as possible, and based on sound science, identifying where the challenge is coming from and how best to isolate it and resolve it. So thank you so much. Mr. Benson, that completes item 7B. Any announcements for the committee or the community before we adjourn?
Thank you, Mr. Chair. Only that as we discussed earlier, our plans are to cancel our June 15th meeting. So the next meeting of the committee will be July 20th, and that will be at the David Gephardt Public Meeting Room.
Would it be appropriate as a prelude to adjourning at Mr. Hawkins' last meeting to wish everybody on the committee, the staff, and the community a safe and happy and thoughtful Memorial Day weekend? And 4th of July as well. Is that a motion to adjourn, Mr. Smith? Is there a second? Second. All right, it's been moved and seconded that we adjourn at 6:35. All those in favor signify by saying aye. Aye. Are there any opposed? All right, we are adjourned. Thank you.